Welcome to Solving Linear Systems by Elimination. So to solve a linear system by elimination, the first thing you want to notice is that the equations have to be set up in the same form. So you can see here for both of these equations, I have the x first, I have my y term second, I have an equal sign, and then my constants. The equation can be in a different form, but they do have to be matching. Otherwise, we won't be able to use elimination without a bit of rearranging going on. So to start off with, we're going to label each equation, number 1 and number 2. For step 2, you either pick the x or the y terms to eliminate, basically get rid of it, and you solve for the other letter. There are some instances where one may be easier to go for than the other or involve less work, but either way, you can pick whichever you like and you'll be able to solve this no problem. So for this particular example, I'm going to go ahead and just pick the x term. So what I'm going to do is look at the coefficients of my x terms, and I have 6 and 1 as the coefficients. And I have to find the lowest common multiple for the x terms. Lowest common multiple between 6 and 1 is 6. So you can see that equation 1 already starts with that number, 6. So I'm going to multiply equation 1 by 1. Ultimately, I'm going to do nothing to it, because when we multiply by 1, nothing changes. Equation 2, I'm going to multiply by 6. And what that's going to do is change this first term so that it is exactly the same as this first term. When you multiply that second equation, you have to multiply every part. So we start off with the 1x times 6, which gives me 6x. The 1y times 6, which gives me 6y. And 14 times 6, which gives 84. Now what I want to do is eliminate that x term by either adding or subtracting the two equations together. So this here is equation number 2, which I've changed. I'm just going to rewrite equation number 1 right underneath it. So I have 6x plus 5y equals 32. Because these numbers are exactly the same, they have the same sign, positive and a positive, you're going to subtract the equations. If we had opposite signs like 6 and negative 6, you would be able to just add the two equations together in order to eliminate. So in this case, we are going to subtract the equations to eliminate the x term. So I'm just going to put a nice underline here, showing what I'm doing. And then I am going to draw myself a nice big subtraction sign here so that we don't forget what we're doing. It's really common to forget to subtract and start adding midway through, so I like writing it nice and big. So first off, we do 6x minus 6x, which gives us 0x. 0 times any number, you got it, it's always going to be 0. So we have eliminated the x term. Then we're going to move on to the y's. So we have 6y minus, don't forget your big subtract sign, positive 5y. So 6 minus 5 is 1. We're left with 1y. 84 minus 32, we get 52. And of course, 1y is the same thing as just saying y equals 52. And that is now the first part of our point of intersection. Just like elimination, the rest is the exact same. You take that y value, you take your y equals 52, and you pick one of your two original equations, and you substitute it in to solve for the other variable. So in this case, I'm going to grab x plus y equals 14, substitute in y equals 52, and solve the equation for x. So subtract your 52 on the other side, and we get negative 38. My point of intersection then is negative 38, comma 52. Last thing to do is our left side, right side check. So we're going to go ahead and grab that original equation, 6x plus 5y on the left, 32 on the right. Substitute our numbers in, x for x and y for y. Using BEDMAS, multiplication first. And we find that our left side is equal to our right side. Therefore, our point of intersection is correct. And that's it. So with elimination, you can see the setup is a little bit different. We don't need an equation of y equals or x equals. We don't isolate that variable. We just add or subtract the equations together, possibly with some multiplication required first. And then all the rest of the steps are the same substitution. So let's move to the next example. So with this example here, label my equations. So equation 1, equation 2. And I'm going to pick either x or y. Maybe this time, just for the heck of it, I'm going to go with the y term and show you how that would work. So the lowest common multiple of the y, so I have 3 and negative 2. I actually don't need to worry about the negative, because what can happen if you have one positive, one negative, when we get down to the eliminate step, is we actually get to add, which is much easier than having to worry about subtracting negatives. So I'm just going to look at the numbers, 3 and 2. The lowest common multiple is 6. So what do I need to multiply 3 by to make it a 6? I would have to multiply it by 2. So we're going to multiply that whole equation by 2. The second equation, I've got the 2, actually a negative 2, but won't pay attention to that for now. 2 times what gives me 6? It would be a 3. So right now I'm just going to multiply my two equations. So the first one, 4x, so I'm just looking up here, times 2 is 8x. 3y times 2, 6y. And 3 times 2 is 6. There's the first one. The second one, 3x times 3, 9x. Negative 2 times 3, negative 6y equals, and then we've got negative 19 times is negative 57. So this is equation 2, and this one's just a variation of equation 1. And we continue from here. So when we look at the numbers now in front of the y, you can see that they have opposite signs. If they're opposite signs, we're able to add the two equations together. So I'm going to throw this plus sign in here, but usually we don't forget to add. The subtraction we tend to forget. So we're going to add the equations to eliminate the y's. That's our goal here. And underline, and let's do it. So we have 8x plus 9x. Add them together, we get 70x. 6 plus negative 6 is 0y. But guess what? 0 times any number is always going to be 0. And we have effectively eliminated it. I like to always have you double check. Positive 6 plus negative 6. Add it. Make sure you're getting 0. If you're not, you might be doing the wrong thing, the wrong operation. And here we have 6 and negative 57, which gives us negative 51. Continue on to solve the equation. Divide out your 17 on both sides, and we get x equals negative 3. Once you have the first half, we've eliminated it. We're going to solve for the other variable. All right, so that equation we're going to grab from the top, 4x plus 3y equals 3. We're going to take that value we just solved for, so x equals negative 3, and substitute it into equation 1 and solve for the other variable, solve for y. So 4 times negative 3 plus 3 times y equals 3, negative 12 plus 3y equals 3. Add the 12 to the other side, and finally dividing out by 3. Our solution then is negative 3 for your x, positive 5 for your y. I'll just cancel this out. We only have to do it once. So we're going to grab the other equation, 4x plus 3y equals 3. We used in that last step. So we need 3x minus 2y equals negative 19. Substitute our values. Dead mass, we do our multiplies first, and then our subtraction. And we get left side equals right side. Therefore, our answer is correct. On the next page, you guys have one to try yourself for elimination. So it does require you to do some multiplication. You can see the little tip up at the top. You have to choose whether you're going to eliminate the x's or eliminate the y terms, and it's up to you which one you go with here. Pause the video, try the question, and then come back and check in and see how you've done. Pause it now, please. Stop cheating. Pause the video. Alright guys, so here you are back. This is the answer. I decided to go with eliminating the x's. If you chose the y's, that should be fine. The only difference is your first number solved for, the first variable solved for, will be the x, so you would have gotten x equals 2. No big deal. So one thing I wanted to point out with this one though is when we go subtracting, this eliminates, but we also get these 40/40s sitting over here that also eliminate. Not a big deal. Go ahead, keep solving it, keep working through, and you'll notice that's because the y value is 0. Then you go ahead, solve for the x by substituting in 0 for your y value, and you get the other half. So your point of intersection is 2, 0. So just another thing I wanted to point out is you can do this when equations are in different forms, as long as they're consistent with each other. So there are two other examples, which I've got examples just to show you really quick here. So this is an example in standard form where everything is on the left and it's equal to 0. So once you set up those same numbers and you go to do your add or subtract, don't lose the zeros on this side. Okay, so just be careful if you're ever doing a question like that with elimination. Don't have these things disappearing. And same if you had something like this one. They're both in y equals form. I personally would just go ahead and do substitution because you've already got them set up for y equals. But because they both have that positive 1 in front of the y, we could also do elimination and just subtract. 1y minus 1y though is 0. You need to keep that and your equal sign. Otherwise the left-hand side of this equation just gets lost. And we end up doing our subtraction here and we don't have our equal sign or our equation anymore. Nothing left for us to solve. So possible. In this scenario though, I would preferably myself do substitution. This one as well, if you want, you could rearrange and move that constant over before you go and try to do elimination. Not a big deal though. It's possible to do. So that's it for today's video, guys. See you in class.